Integrated circuits, or ICs, are tiny electronic devices that have revolutionized the world of technology. They're essentially miniature circuits that contain millions or even billions of transistors. These transistors work together to perform complex functions. ICs are found in almost every electronic device we use today. They power our smartphones, computers, cars, and countless other gadgets. Without ICs, our world would be a very different place. Imagine a world without smartphones, laptops, or the internet. This is the world we would be living in without the invention and development of integrated circuits. These tiny marvels of engineering have allowed us to shrink electronic devices while simultaneously increasing their power and functionality. The story of the integrated circuit is a fascinating one. It is a story of brilliant minds, groundbreaking inventions, and relentless innovation. From the invention of the transistor to the development of modern microchips, the journey of ICs is a testament to human ingenuity. It is a journey that has transformed our world in countless ways, and it is a journey that is far from over. The story of the integrated circuit begins with the invention of the transistor in 1947. This groundbreaking invention took place at Bell Labs. Three physicists, John Bardeen, Walter Brattain, and William Shockley, were responsible for this revolutionary device. The transistor, made from semiconductor materials, could amplify electronic signals. This ability to amplify signals was crucial for the development of modern electronics. Before the transistor, bulky vacuum tubes performed this amplification function. Vacuum tubes were inefficient, unreliable, and generated a lot of heat. The transistor was smaller, more efficient, and more reliable than vacuum tubes. This made it possible to create smaller and more powerful electronic devices. The invention of the transistor paved the way for the development of the integrated circuit. In 1958, Jack Kilby at Texas Instruments and Robert Noyce at Fairchild Semiconductor independently developed the first integrated circuits. Kilby's prototype used germanium, while Noyce's version utilized silicon. Silicon eventually became the preferred material for ICs due to its superior properties. The 1970s witnessed another major leap forward in integrated circuits, the invention of the microprocessor. In 1971, Intel released the Intel 4004. This was the first commercially available microprocessor. This tiny chip contained all the central processing unit (CPU) functions of a computer. It ushered in the era of personal computers. This breakthrough led to an explosion in computing power and a miniaturization of devices. The impact of the microprocessor on society is immeasurable. It has transformed the way we work, communicate, and live our lives. The advancement of IC technology is guided by Moore's law. Gordon Moore, co-founder of Intel, observed in 1965 that the number of transistors on an IC doubles approximately every 2 years. This observation, known as Moore's law, has held true for several decades. It has driven the semiconductor industry to constantly innovate and find ways to cram more transistors onto smaller chips. The future of integrated circuits is full of exciting possibilities. Researchers are exploring new materials and manufacturing techniques to continue Moore's law's trajectory. Three-dimensional integrated circuits, 3D ICs, are being developed. These 3D ICs stack multiple layers of transistors on top of each other. This allows for even greater density and performance. However, this miniaturization also presents challenges. Heat dissipation, quantum tunneling effects, and manufacturing costs are becoming significant hurdles. The industry is investing heavily in research and development to overcome these challenges. Sustainability is also a key concern. The production of ICs is resource-intensive and can have a significant environmental impact. The industry is increasingly focused on developing sustainable design practices and manufacturing processes to minimize its environmental footprint. This includes using less hazardous materials, reducing water and energy consumption during manufacturing, and designing for recyclability. The evolution of integrated circuits from simple transistors to incredibly complex microchips is a testament to human ingenuity. As we look to the future, it is clear that ICs will continue to play a vital role in shaping the technological landscape. From artificial intelligence and machine learning to quantum computing and beyond, the possibilities are endless. The journey of the integrated circuit is far from over, and the next chapter promises to be even more remarkable than the last.